Hello, welcome back to our series on LangChain4j framework. Today in this tutorial, we are going to see how we can connect LangChain4j with LLMs that are running within the Docker. Now, when it comes to the Docker desktop, it provides a feature called Docker Model Runner, which allow us to download and run the AI models locally. If we have to make use of the Docker Model Runner feature, first we need to make sure the version of the Docker that we are running is 4.40 or higher. In our case, we are making use of version 4.59.1, which is mentioned at the bottom right of the screen. Now, when you open the Docker desktop application, on the left hand side, you will see an option with name models. When you click on it, by default, it will list all the models that you have downloaded from the Docker. In our case, we have already downloaded one model with name Gemma 3 1 billion parameter. And if you have to look for what all models that are provided by Docker, we need to click on the Docker Hub, where you will see many of the models are listed. And if you are looking for any particular model, we can make use of the search bar and type the name of the model. So in our case, we are looking for the Gamma model, and when we click on Gamma 3, here you will see there are many different variants available for the Gamma 3, and in our case, we have downloaded the Gamma 3 1 billion parameter model, and the size of the model is 768 MB. And if we have to download this model, all we need to do is we need to click on this pull button. Once the model is downloaded, it will be listed here. We can interact with this model. For this, all we need to do is we can click on this run button. It will open the chat window. Here we can type our query and model will respond accordingly. Now one thing to note here is when we will send the first request, at that point the model will be loaded into the memory. So the first request might take some time, but subsequent requests will be faster. For example, I will send my first query, what is Spring Boot? So at that point, you will notice the model is getting loaded into the memory. So if we look at the activity monitor tab, here you will see there was a sudden spike in memory consumption wherein the model was loaded, and you will notice the model has responded to our query. Now if we ask the follow-up question, the response will be faster. So this is how you can download and test the model within the Docker desktop itself. Now we downloaded and tested our model within the Docker, but this particular model is running in isolation within the Docker environment itself. If we want our applications like LangChain4j to interact with these models, we will have to expose this model outside of the Docker. For this, there is one option available within the Docker settings which we can enable, and the name of the option is Enable Host Site TCP. So when we will enable this option, our model will be available over a particular port which is 12434, and we can customize it if required. And if we have to interact with our model, we can send the REST request to this particular endpoint, which is /engines/llama.cpp/v1. Now coming back to the Docker desktop application, here you will notice the settings icon. When you click on it, you will find an option with name AI, under which you will notice in our case the Docker model runner feature is already enabled. And if we have to expose our model over the REST API, we can enable this option with name Enable Host Site TCP Support. By default, our model will be available over port 12434, and we can customize it if required. Now you will be able to understand this diagram completely. First, we need to download the Docker desktop application within which we can search for our required model and download the same. Once our model is downloaded, we can interact with the same with the help of chat feature which is available within the Docker desktop itself. And when we will send our first request, at that particular time, the model will be loaded inside the memory. And if we have to expose our model outside of Docker environment, we can do that with the help of host site TCP option, which is available within the Docker settings. And once this particular option is enabled, our applications can interact with these models with the help of REST endpoint that is mentioned here. Now, one important point to note here is the model that is running within the Docker will be automatically unloaded after 5 minutes of inactivity. So when you will send your next request at that particular time, the model will be loaded again inside the memory. Now we are going to develop a very simple REST-based chat API with the help of Spring Boot and LangChain4j framework, which will interact with the model that is running within the Docker. So this is how the overall request flow will look like, wherein user will send the REST request to our application. Then LangChain4j chat model will send the request to the model that is running within the Docker. Once the request has been received, the model will process our request and send back the response, which will be ultimately sent back to the user. So this is how our overall project structure will look like, wherein the name of our application is LangChain4j chat model Docker demo. At the very top, we have the Spring Boot main class. Then we have simple chat controller containing one REST endpoint for accepting the request from the user. And once the request has been processed, it will simply send the response back to the user. Then inside the resources folder, we have the application.yml containing the model configuration. And then we have the pom.xml containing project related configuration. Now let's go through our code base, starting with the pom.xml. At the very top, you will notice we are making use of Spring Boot version 3.5.10. When it comes to Java, we are making use of version 21. And for LangChain4j, we are making use of latest stable version, which is 1.11.0. Coming to the dependencies section, first we have added the Spring Boot starter web dependency, which will help us to create the REST APIs. Then we have added the LangChain4j OpenAI Spring Boot starter dependency. Now when it comes to the models that are running within the Docker, the response that are provided by them are compatible with the OpenAI standard. That is why we have added the OpenAI specific dependency. Coming to the dependencies management section, we have added the LangChain4j BOM for the version management. Now coming to the application YML, at the very top we have defined the name of our application. Then we have defined the configuration related to our model with the help of the properties that are offered by the LangChain4j framework. So first we are setting the base URL and it is pointing to localhost 12434. So this is the port over which our model is available. Then we have defined the base path as /engines/llama.cpp/v1. Then we have set the API key to some dummy value. Now when it comes to the models that are running within the Docker, they don't need any API key. But LangChain4j requires the API key to be set. That is why we have added some dummy value here. And when it comes to the model name, we will be interacting with the Gemma 3 1 billion parameter model, which we have already downloaded within the Docker. And here we need to provide the exact same model ID that is mentioned inside the Docker desktop. So if we go to the Docker desktop, here you will see the ID is docker.io Gemma 3 1 billion. So same we need to provide it here. And for logging request and response, we are just setting these two flags to true. Next, we have the Spring Boot main class. This is the standard Spring Boot main class which will bootstrap our application, and also it will auto-wire the chat model with the help of the properties that we have defined within the application.yml. Now coming to the controller package, we have simple chat controller. Inside this controller, we have created one simple chat endpoint using which user can interact with the model that is running within the Docker. So at the very top, we have defined the base path for our controller, which is /API/v1. Then we have created simple chat endpoint, which is of type post, and the path suffix is /chat. In order to accept the request from the user, we have defined the type as map of string. In this particular case, user will send the JSON request containing information in the form of key value pair, which will be mapped here. And once the request has been processed, we will send the JSON response back to the user, for which we have defined the type as map of string of object. Now if we expand this method, here you will notice from the request, we are extracting the query which is asked by the user, and here we are assuming the query will be present inside this field, which is message. Once we have extracted the user query, we are storing it inside the variable. Now we need to send this query to the LLM which is running within the Docker. And in order to send the request to the LLM, we can make use of the chat model interface which is provided by the LangChain4j framework. So here you will notice the chat model is getting auto-wired. Once we have the chat model, we can make use of the chat method within which we can send the query which is asked by the user. Once the model has processed our request, it will give us the response in the form of string, which we are storing it here. And once we have the response available from the LLM, we need to send the JSON response back to the user, for which we are creating the map of string of object here and storing the response which is sent by the LLM inside this particular key, which is AI response. Once the map object is ready, we are simply returning it back to the user. Yeah, so this is how we can create a very simple REST based chat API which will interact with the model that is running inside a Docker. Now our application is ready, we can simply test the same. But before that, you need to make sure the model that you have mentioned here is available within the Docker. Now let's start our application and test our REST API. So our application is started. And in order to interact with our REST API, we need to send the request to this particular endpoint, which is /API/v1/chat, which is a post type of endpoint. And inside the request body, we can ask our query, and we need to specify our query inside this particular field, which is message. As soon as we will send our first request, the model gets loaded inside the memory, which will process our request, and we should see the response here. So as soon as we will send the request, here you will see the sudden spike in the memory. So let's send our request. So here you will see we are noticing the spike in the memory, and behind the scenes the model is processing our request. And once the request is processed, we should see the response here. Since this is the first request and the model is getting loaded inside the memory, it will take certain time. The subsequent request should be faster. So here you will see we have received the response and it took around 30 seconds to process our request. Now if we will ask the subsequent query, it should be faster. So now you will notice the request took around 15 seconds to be completed. Now if you look into the application log, you will notice the request was sent to the port 12434, and the base path that we define inside the application.yml is also mentioned here, which is /engine/llama.cpp/v1. And since our query was text based query, the request was sent to the chat completion endpoint. And here you will notice the request was sent to the Gemma 3 model, which is running inside the Docker. The request content is also mentioned here. And when we receive the response back from the LLM, it is also getting printed here. Now I would like to showcase you two important commands related to the Docker models. First one is how we can check what all models are currently loaded inside the memory. And the second command is related to unloading these models from the memory in order to free up the system resource. So first, if we have to check what all models are loaded inside the memory, for that we have this command, which is docker model ps. This will list down what all models are currently loaded inside the memory. In our case, we have one model with name Gemma 3. Now if we have to unload all the models, or if we have to unload a particular model, this is how we can do. For that, we need to type docker model unload. And if we have to unload all the models, then we can type all. If we have to unload a particular model, then we can specify the name of the model. So here you will see one model is unloaded. Now if we check the output of docker model ps command, here you will see none of the models are listed. Here you will see there is a sudden drop in memory consumption because the model was unloaded from our system memory. Yeah, so that was all regarding how our LangChain4j application can interact with the models that are running inside a Docker. For this, we have also written one detailed article which you can go through if you are interested. Also, the code base that we discussed during this tutorial is uploaded on GitHub. You can simply check out the code and try the same. Yeah, so that was all from my end. I hope you found it useful. Thank you.